Welcome to the notes page for Finding Volume. You'll notice that this covers lessons 1, 2, and 3 in our iReady lessons, and we're going to cover a couple different steps to finding volume. To start, you will need something to write with, and we're going to use lots of colors today. So these are all the different colors we're going to be using. I've got purple, red, green, pink, yellow, and blue. Please find those colors. You can use crayons, colored pencils, markers, whatever works for you. If you're missing a color, you can always go look in the color bin to see if there's a replacement or decide what you're going to use as a replacement color today. Go ahead and pause the video until you have your supplies ready and then restart it. All right, so you should have your supplies. Let's get started. The first skill for this unit is I can count visible and inferred unit cubes to determine the volume of a figure. Remember, the word volume tells us I'm talking about the space inside. When I say volume, I don't mean a flat surface or just a line. I mean all the space inside this figure. Our first step for counting visible and inferred unit cubes is to find the number of cubes in a layer that you can see. So when I look at this, I can see there's a top layer, a side layer, and a front layer. You could pick any layer that you want. I'm going to pick this front layer, and I'm going to chop it off with my writing tool. Now, I'm not really chopping, but I'm pretending that I'm taking some sort of invisible kitchen tool and I'm chopping that layer off. That is one layer. And then I'm going to take my blue and I'm going to color that first layer in blue. I'm thinking about what it would look like if I just took one layer of those cubes and pulled it away. I'm going to look at just that layer. Now when I look at this layer here, this is my first layer, I can count how many cubes are in it. I can see that there's one cube here, and there's another one here, and another one here, and another one here, and here, and here. This first layer has 6 cubes. I didn't write numbers here because this is another side of cube 1, and this is another side of cube 1. Just like this part here is just the other side of cube 4, this is the other side of cube 2, and this is the other side of cube 3. So I'm not labeling every face, every surface, I'm just labeling how many cubes. In this layer, it has 6 cubes. So I did the first step. I found the number of cubes in a layer that you can see. And I'm going to color that word layer in blue. So if I look at my notes later, I can remember, oh, that's what I mean by layer. My next step is to determine how many total layers we have. So we colored our first layer blue. Behind it, I can see I've got another layer right here, and another layer right here, and another layer right here. So I'm going to color each layer a different color. It doesn't really matter if you match my exact color order, but it will make your notes easier to see. So there's another layer. Here's another layer. And another layer. And one more layer. When I look at this figure, I can count all the layers. I can see I've got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 total layers. So when I look at that, I can say all together there are 5 layers. Each layer has 6 cubes, and there are 5 total layers. So I was doing that over here. Determine how many total layers. Now our job is to multiply the number of cubes per layer times the number of total layers. So if I have 6 cubes per layer and I have 5 layers, then altogether I have 30 cubes in this figure. This is the idea behind concept number 1 that says, I can count visible and inferred unit cubes to determine the volume of a figure. If you need a minute to pause and finish up the notes for this one, go ahead. When you're ready, unpause the video and we'll continue. All right, so now let's move on to the next skill. The next skill says, I can use the volume formula to determine the volume of a rectangular prism. Well, let's start with this here, this volume formula. To figure out the volume of any rectangular prism, remember a rectangular prism is a shape where all the faces are rectangles. To determine the volume, I can simply say volume equals length times width times height. If I know how long something is, how wide something is, and how high it is, I can figure out this space inside. I can figure out its volume. So let's start here with length. I'm going to get my green. I'm going to trace that L in green. My length. Looking at the shape, length means how long something is, and that's right here. That's my 5. And in fact, this one doesn't have a unit. I'm going to ask you to add that. Let's add cm for our unit. We're going to be working in centimeters for this figure. So this figure has a length of 5 centimeters. We found the length. Now let's find the width. We're going to use yellow for the width. Aha, here's my width. That's how wide it is. And it is 4, I'm going to ask you to add cm, 4 centimeters wide. And last, and then we'll do W in yellow. And last we have the height. I'm going to do that in red. The height is how tall it is, how high up it is. It's 6 centimeters high. We found the dimensions for this figure. So we can say I can figure out the volume. I just need the volume. I need the length. That's 5. I need the width, how wide it is. That's 4. And I need the height. And that's 6. My length, I'm going to color in green. There it is. My width, I'm going to color in yellow. And my height, I'm going to color in red. All I need to do is do the calculations now to figure out the volume. Length times width times height. First, I'm going to multiply these two pieces. 5 times 4 is 20. I'm going to bring down what I haven't used. And now I'm going to multiply 20 times 6. I know 2 times 6 is 12. Multiply that by 10. So my volume for this figure is 120. Now let's figure out the label. I have centimeters, centimeters, centimeters. So my volume will be cubic centimeters. Centimeters to the 3rd power, cubic centimeters. Sometimes they'll give you a figure with the length, width, and height written on it to show it like a diagram. Sometimes they won't. Sometimes they're going to give you a story and you have to figure out where the length and the width and the height are and use them to figure out the volume. Here's an example. Mrs. Yandersitz has a prize box in her classroom that is 18 inches long, 10 inches wide, and 8 inches tall. What is the volume of her prize box? So they're describing it, and I need to picture it. So we know it's a box. I'm going to start by drawing a rectangle, and then I'm going to draw the 3rd dimension, the 3-dimensional sides kind of going off at an angle, and then connect them. She has a prize box. Let's go back in and figure out what data they gave us that we can put into our image. Mrs. Yandersitz has a prize box, we drew that, in her classroom that is 18 inches long. That's the length, 18 inches. 10 inches wide, that's the width, 10 inches. And 8 inches tall, that's the height, 8 inches. What is the volume of her prize box? So I've got the dimensions. My job now that I've pictured it, is to use my volume formula. We remember that volume equals length times width times height. So first, let's see if we can find the length. Where's the length in this? Aha, here's the length, 18 inches. And then we need to find the width. The width is how wide it is, 10 inches. And then we need to find the height. The height is how tall it is, 8 inches. Once I have found all those, I can just write it out like an equation to solve. Length times width times height. Now it's time to multiply. 18 times 10, that's 180, and I still need to multiply it by 8. Uh-oh, this isn't a fact I can do in my head. Anytime I hit multiplication, that's more than I can do in my head, I just set it up standard algorithm style. 180 times 8. 8 times 0 is 0. 8 times 8 is 64. 8 times 1 is 8, plus 6 more is 14. So altogether, that's 1,440. Now I need my label. I was working in inches, and I have volume. Inches times inches times inches. So my answer will be in cubic inches. The volume of Mrs. Yandersit's prize box is 1,440 cubic inches. If you need to pause to catch up on any of the notes, do so now, and then resume the video when you're ready. Let's move on to the next piece. The next piece says, I can determine the volume of a figure when given the area of a side and a third unrelated measurement. Unrelated is really important. Let me show you what I mean. Here's an example where you might see a diagram, and it's your job to calculate the volume. Looking at this diagram, I know that they told me this measurement, that's the width. And then they told me this measurement, that's the length. And then they gave me this other piece of information. They told us the area. I'm going to ask you to grab your pink crayon. Let's color in what area we're being given. We're being given the area of this face, this rectangle on the side of this box. Thinking what we know about volume, did they tell us the length and the width and the height? Well, I've got the width. I've got the length. What's missing? Yeah, we don't know the height. So I can't do my standard length times width times height strategy. Instead, I've already been given the area of this figure. Let's think about what this area tells me. To figure out this area, they must have multiplied the two sides of this shape. They multiplied the length times the height. They told me length times height equals 15. So now I'm going to use that in my volume formula. Volume equals length times width times height. And I know length times height already. So I'm going to rearrange this. I can also write it volume equals width times length times height. Look how I just moved these around. Since it's multiplication, that doesn't change my final answer. Length times height, we already know. It's 15. And width, we know, is 4, right here. Now I can do my multiplying. Volume equals 4 times 15. 15 plus 15, that's 30. And if I do that again, that's 60. My volume is 60. Now I'm going to figure out my label. I've got square centimeters and centimeters. If I'm doing volume and I'm working with centimeters, I know my answer will be centimeters cubed, or cubic centimeters. Basically what I did here is I figured out which of my two measurements was unrelated. This one I didn't use because it was already here in the area. This one is a related measurement. It was already here in the area, but this one was an unrelated measurement. This one they hadn't already given us info about. So sometimes you'll get a figure. Other times you're going to get an example. They're going to give you a story problem and you have to figure out what to do with the info. This one says, Adam's little brother built a block tower in the shape of a rectangular prism. It is 6 cubes high and has a base of 4 cubes. What is the volume of the tower in cubes? So let's draw the tower. To draw the tower, I'm going to draw one face of it. I think I'm going to draw the front face. And then let's draw those lines going back. This is my visual imagining of that block tower. Let's go back into the problem and figure out what information they gave us. Adam's little brother built a block tower in the shape of a rectangular prism. Got it. All the sides are rectangles. It is 6 cubes high. Ooh, that's how high it is. Height equals 6. And has a base of 4 cubes. Base of 4 cubes. Let's think carefully. When they say it has a base of 4 cubes, what they really mean is that bottom layer contains 4 cubes. So to make this drawing even more realistic, I'm going to show all the cubes hiding in it. I know it is 6 cubes high, so I'm going to try to draw that. 1, 2, 3, 4, 5, 6. So that shows how high it is. And let's think about that base. They told us the base is 4 cubes. If I picture it in my mind, I can picture there's 1 cube, 2 cubes, 3 cubes, and then that 4th one is going to be hiding back there. That base is like a layer. Base equals 4. If my bottom layer has 4 cubes, I can infer that there's also 4 cubes in this layer, and 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 4 cubes in this layer. In fact, I could even draw to show that here on top and connect it on down. It's a lot like our first problem where we figured out the layer and then figured out the total number of layers. For this problem, the base has 4, and I'm going to multiply it by the number of layers. There are 6 layers. 4 times 6 is 24 cubes. If you need to pause the video to catch up, do so now. Restart it when you're ready. The final skill that we're working on is I can determine the volume of complex figures by breaking them up into rectangular prisms and combining the total volumes. Let's talk about what all those different things mean. This first piece, complex figures, means it's not just a rectangular prism anymore. It looks like a couple different rectangular prisms pushed together. So complex figures aren't simple like we had earlier where it was one rectangular prism. Complex figures are made of multiple shapes. And we're going to break them up into rectangular prisms. We're going to use our slicing into layers strategy, and then we're going to combine the total volumes. To make this work, let's start first by deciding how can we cut this up so that we have 2 or more rectangular prisms. Well, when I look at it, I could cut here, bring this line straight back, and make that one rectangular prism and another rectangular prism. So that's one way we could do it. Or I could cut this way. Now I have this rectangular prism and this rectangular prism. I think that's how I'm going to choose to do it today. I am going to call this figure A, and I'm going to call this figure B. Our job is to figure out the volume of figure A and the volume of figure B and then combine them. So let's start here with figure A. I'm going to write volume, and then I'm going to put a little A down here. The volume of A. And we know volume is always length times width times height. So let's look here and see if we can figure out for figure A, where's my length? Aha, there's my length. So volume of A equals 2, there's my length. Let's find my width, how wide it is. So A goes like this and like this. And I can see it is 2 feet wide. And now I need to figure out how high it is. Right here, it is 3 feet high. Volume of A equals 2 times 2 is 4. I still need to multiply by 3. 4 times 3 is 12. 12, and my label is feet. Since I'm working in volume, it's 12 cubic feet. All right, we figured out the volume of A. Now we need to figure out the volume of figure B. To do so, I'm going to write V with a little b at the bottom, volume of B. And again, our volume strategy is just length times width times height. Let's see if we can figure out all of those measurements for figure B. So here's figure B. I need to figure out how long it is. I need to know how long this guy is. Now careful, I can see it looks like there's a 4 right here for length, but that only goes to here. That would stop right here. So this piece is 4 from here to here. I need to figure out what this is worth. And if I look right here, I can see, aha, this length is the same as this length, is the same as this length, is the same as this length. So this piece is 2 feet. The total length of figure B is 2 feet plus 4 feet. So I know my length is actually 6 feet. Now I need to figure out the width. So again, here's figure B. I need to know how wide it is. Awesome, it's 2 feet wide. And I need to figure out the height. Ooh, there's no label there. I'm gonna have to keep looking. That's the same as this, but no label there. That's the same as this. No label. It's just as high as this, but no label. Aha, it's also as tall as this, which is 3 feet. So my height is 3 feet. Sometimes the label's not where you want it, and you have to go looking for other lines that are the same height. Now that I know my length, my width, and my height, I can multiply. 6 times 2 is 12. I'll multiply that by 3. The volume of figure B is 36 cubic feet. So I figured out the volume of this piece and the volume of this piece. Now I want to find the total volume. To do so, I'm going to add the volume of figure A plus the volume of figure B. Volume total equals the volume of figure A plus the volume of figure B. So figure A is 12 feet cubed. Figure B is 36 feet cubed. My total volume is 48 cubic feet. These are the skills in finding the volume of rectangular prisms or complex figures. If you need to re-watch any part of this, you can always start over and fast forward or rewind to where you need to be. Please have your notes out while you're working through our activities. Good luck. Good luck.